Today, the time reversal property we have to learn. Now, the statement of time reversal property is reversing the endpoint sequence in time is equivalent to reversing the DFT sequence. Okay. Now here, reversing the endpoint sequence. So that's why in time it is directly proportional to the reversing the DFT sequence. So that's why here the endpoint sequence here we are considering. So that's why we will say here the DFT of x of n is x of k. Now here we will go for reverse. So that's why the reverse of this n is n minus n. So DFT of x of n minus n is nothing but x of n minus k. Now here we have to prove it whether this will be satisfied with the help of time reversal property. Now we know the definition of x of k. So what the definition of x of k says? It is summation of n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi n k by n. Now to prove it, the time reversal property we say here DFT of x of n minus n is equal to summation of n is equal to 0 to n minus 1 x of n minus n e raised to minus j 2 pi n k by n. Now here this n minus n is the term that will be present here with x. Now to prove it as per our definition, here x of n should be present. So here we will write here n minus n is nothing but m. Okay, so that's why we say m is equal to n minus n. Okay, now what is n? N is nothing but n minus m. Now we put it in our expression. So that's why we will say here summation of m is equal to 0. Now limits are also changing. Instead of n, m will be here. So that's why m is equal to 0 to n minus 1. Similarly, x of, now here n minus n is replaced as a m. Okay. Similarly, here this n that we have finded here, that n we will replace from the exponent term. So that's why here e raised to minus j 2 pi k. Okay, now n term is there, so that's why n is replaced as a n minus m, and at the denominator there is a n. Okay, now we expand this exponent term. Okay, in this exponent term you can find n minus m, so that's why we separate n term separately and m term separately. So that's why we write here summation of m is equal to 0 to n minus 1 x of m e raised to minus j 2 pi k n. Okay, 2 pi k n divided by n. Okay, and the second one term is here into e raised to minus j 2 pi k m by n. Okay, now from this term here n divided by n is present, so we will say here both are cancelled, and only the e raised to minus j 2 pi k term will be present. So that e raised to minus j 2 pi k, k is here a constant term. Okay, here it is an integer term. So that's why we will say if it is an integer term, we will replace it as a 1. Okay, so that's why in our numerator, in our we can modify, we write the modified expression. Okay, now here I write here is equal to summation of m is equal to 0 to n minus 1 x of m. Now 1 is here, so that's why I write here directly e raised to minus j 2 pi k m by n. Okay. Now this term will be getting. Now here, if you compare this term with our definition of the DFT, then here x of m will be present here. Okay, no problem. M is here present. Okay, no problem. But here the term here the minus j 2 pi is okay. Sorry, here it is a positive term. Okay, here it is a positive term. So that's why here the exponent term will be positive. So that's why here, because of that positive term, here we cannot able to match with our definition. Now here, what we have to do, we will go for some arrangement. I say here, summation of m is equal to 0 to n minus 1 x of m e raised to j 2 pi m k by n into 1. Now, as we see here, it is an exponent term, and in this exponent term, minus j 2 pi m 2 pi k will be an integer term. In the same fashion, here I consider a integer term. Okay, I see here 1 is nothing but e raised to minus j 2 pi. Now here I need a m name term, so that's why I consider here m. Okay, so that minus e raised to minus j 2 pi m term I consider as an integer term, and I put it in the expression. Okay, so here I write here the modified term m is equal to 0 to n minus 1 x of m e raised to j 2 pi m k by n into e raised to minus j 2 pi m. Okay, now this term I put it instead of 1. Now I say here the n term will be present at the denominator. Here n term is not present in the denominator, so I write here the multiply and divide by n. Okay, so that's why both are get cancelled, and we will get a expression that is integer term. Okay, now again I go for combining this exponent term. So that's why I write here summation of m is equal to 0 to n minus 1 x of m. Now here this exponent and this exponent will be equal 1. Okay, now here j 2 pi m will be common. Okay, j 2 pi m will be common. Okay, now here n will be present in the denominator. Here n is present in the denominator, so I write here n will be present. Okay, now here the minus term is linked with the n term. Okay, here plus term is linked with k. Now here I see here minus n. Okay, so that's why minus n. Okay, and here plus k will be there. Okay, now here from this expression I take minus term common, so that's why minus term will be coming here. So e raised to minus j, it will becomes plus, so that's why I replace it as a plus, and this my positive term will get minus. Okay, so that's why it will be minus. Okay, so that's why I will get e raised to minus j 2 pi m by n in bracket n minus k. Okay, so here as per the definition, here this term is directly matches with our x of k. So that's why here I write here it is nothing but x of k, that is n minus k. Okay, so as per the time reversal property, we can say here our time reversal property can get proved. Okay,